Welcome to Wild Wednesday, students. Today I've traveled thousands of virtual miles to see one of the most incredible wonders in the world. There it is! The Grand Canyon, one of the most incredible geologic wonders found on our planet. The Grand Canyon is 277 miles long, up to 18 miles wide in some parts, and at its deepest point is over 6,000 feet deep. For thousands of years, the area has been continuously inhabited by Native Americans who built settlements within the canyon and its many caves. The canyon was first settled and explored by the ancestors of the Puebloan people, indigenous Americans that settled what we now know as the southwestern United States, and known for their incredible cliff dwellings and pottery. It wasn't until the arrival of Spanish explorers in the 1500s that the Grand Canyon became known to Europeans, and was not popularized until an expedition after the American Civil War. The Grand Canyon was classified as the 17th national park in the United States by President Woodrow Wilson in 1919. The park has served an increasing number of tourists and visitors since then, who have come for its beauty, its diverse wildlife, and epic hiking. For most, traveling to the Grand Canyon is a once-in-a-lifetime adventure. But even if you can't make it to the Grand Canyon anytime soon, you can experience what it's like to travel through the canyon on one of those epic trails by reading this book. It's called Grand Canyon, and it's by Jason Chin. One of the forces most responsible for the creation of the Grand Canyon can be found at its bottom, where our book begins. The Colorado River runs the entire length of the Grand Canyon. It's been cutting into the land for around 5 million years, slicing through layer after layer of rock through a process known as erosion. Erosion is the movement of earth matter from one place to another, usually by water, wind, or ice. To demonstrate the power and force of water that causes earth to erode, I've created a little bit of a model here in the Science Center. This may not look like much of anything to you, but to me, it's going to create our own little mini Grand Canyon. As we discussed earlier, water is responsible for carving canyons. When water begins to flow on the surface of an earth through either rainfall or water flowing from another location, like snow melting on top of a mountain peak, that water will always try to find its way down a slope due to the force of gravity. Over time, water will begin to wear away or erode sections of earth that water repeatedly flows on. Now you might be able to see those little bitty pieces of earth, or sand in this case, moving from the top of our erosion table down. You may also notice that land doesn't just magically disappear. Instead, it gets dropped out or added to a new location through a process known as deposition. Erosion is the movement of matter, or in this case, earth rock, from one place to another. What started up in a higher elevation or higher point on Earth's surface was pushed downstream by the water until the water stopped flowing or became too weak to carry that matter any further along, creating a new landform in its place. If we continued to do this over and over and over with new pitchers of water, we would see a formation just like the Grand Canyon begin to be carved out of our sand and moved downstream. My Science Center model gave us a pretty basic understanding of how erosion can change Earth's surface. Let's check out an improved model like the one at Brigham Young University to see just how well models can reflect real-life conditions on Earth's surface.
So, Professor Radebaugh, what is it that makes this stream table so special?
Well, we are so thrilled to have this new stream table. It's from Little River Designs, and it's actually only the fourth one in existence. So if it had a serial number, it would be 4. And it's actually pretty big compared with lots of other stream tables in existence, and there are a bunch of other features we'll show you today that make it really new and unique. The best thing about a stream table is that you can actually study the things that happen in nature, but do it in a confined setting, in a classroom, in a laboratory, and in a way that we can better understand the individual processes. Yeah, so you can actually watch change happen really quickly, and that's something that's unique about this particular stream table. Most other stream tables have quartz sand in them, and so they're really heavy, and the sand takes a long time to respond to the action of the water, but this sand is actually made of plastic. So this thing is ground up salsa bowls from a factory and machined to different sizes. It's actually the yellow is the very biggest of all. And we can see the yellow sitting on top of all these bars over here. Can you tell that? The yellow drops out first and just anchors these bars together, where all the smaller ones kind of go in between and flow along with the water through the channel. So that's a good way for us to see where the fastest water flow is and what has happened to a system over time. One great thing the stream table can do is insert dye into the stream flow. And you can see the dye highlights the deepest parts of the flow, which we might have thought was over on the left, but it turns out is way over on the right. And it also highlights the most rapid parts of the flow because that's where all of the blue dye comes out first. So here we have this deep channel we never would have known about unless we had the dye. Right, we can also control the angle of slope on the stream table, so just crank that down. And as we do that, we notice that more water is flowing out the bottom of the stream down toward the bucket in the bottom. There's a lot of rapid flow down at the end. Okay, now you can see all of these yellow particles coming out. That indicates rapid flow by these yellow bigger particles. And the meanders are changing upstream. Just by tilting the angle of the table, we've changed the entire system. Meanders are straightening out, new ones are forming, and it shows us just how dynamic the whole system is.
Models are powerful because they allow us to see changes that would otherwise need to be observed over millions or even billions of years in just a few minutes or hours. They allow scientists to make predictions about how things have not only been created in the past, but how landforms might change in the future. Rivers carve canyons. They start out just as a slow, meandering river. As the flowing water carries bits and pieces of the earth further downriver, they begin to carve the canyon's shape into the ground. As a result, the canyon grows deeper every day. As time goes on, the water continues to erode away the sides of the canyon, making them grow wider, and more land on those sides falls into the river and flows downstream. Year after year, the river washes all of the eroded material away, continuing to deepen the canyon. Though the river may be just 5 million years old, the rock it has carved through is much older. The oldest rock in the Grand Canyon is believed to be nearly 2 billion years old, and every layer in the Grand Canyon leaves evidence that tells us the story of Western North America's environmental past. Trilobite fossils found in the rock layer known as the Bright Angel Shale is roughly 500 million years old and tells us that the southwest United States was once covered by a shallow sea or ocean, teeming with life. Other layers further up the Grand Canyon demonstrate that the climate of the southwestern U.S. has changed over time, sometimes being a lush, green, wet environment, and other times being dry, desert-like, and difficult for creatures to thrive in. I've made my way down to Burlington's brand new Fire Station number 2. Not to check out that beautiful new facility for our firefighters, but to check out what's right next door. This is the Vine Brook Reservoir, where a large chunk of your water comes from. This water is fueled by small streams that fill in from higher areas around it. Some of the water is also piped into the area. There's a large treatment facility just beyond this tree glade that helps treat that water before it goes out to the businesses and homes of Burlington. I've brought us here because this is an important place to protect, both from trash and debris that might fly from what we leave on the ground by accident, but also from runoff that's picked up by rainwater and in the process that we know as erosion. Now, what's really going on right now that's interesting to see is that we're doing some work here in Burlington on the road that connects the fire station and the Francis Wyman School and many of the residences that our Burlington students live in. Let's go see what's going on. As you can see, they're digging up the sidewalk, or what was the ground to the right of this road, to put in a new sidewalk that's more accessible for folks with motorized wheelchairs and just making this area a better place to travel by foot. But in order to do that, they've had to dig up the ground, and they'll have to put in lots of new building materials. And as they build, they don't want the oils from some of the vehicles they'll be using or some of the other chemicals that they might need to prepare the concrete to seep into the water that's just to their right. So they've put up these big bales of hay, temporary barriers, along with that plastic shield that you see behind it, to help protect those precious waters that we rely on every day to drink. It's important that even as we grow our community and build it out to be a better place for us to live, we also protect what's already here. And that includes the wildlife and important sources of water that we use. This is just one example of the ways that humans try to prevent or slow down erosion processes. They use barriers like these to keep the water from flowing and taking whatever it has with it along for the ride. Let's take a second look at this area from above for some perspective about what's happening. Here we are again at the Vine Brook well fields, or otherwise known as the Vine Brook Reservoir. This green area up close is lush wetlands where plenty of wildlife live and thrive in the water that is continuously flowing into the area through what's known as the Vine Brook. The Vine Brook flows beneath the road Terrace Hall Avenue, which is where I was standing just moments ago by the fire station, sharing with you this new improved road that sidewalk that they're building right along this Terrace Hall Avenue. Of course, you don't have to go to the Grand Canyon to find evidence of erosion. Natural processes like erosion are happening in our environment all the time. Evidence of erosion can be found near and far. Take a look at this picture. What do you notice about the street? Where is it located? What could have possibly caused this street to collapse? How might that happen? What do you think caused this street to collapse? How about this formation, known as a talus slope, found beneath that rock face at the top half of the screen? What do you notice it's made of? What do you notice about the surrounding environment? And what do you notice about what's on top or not on top of the talus slope? Where did the material that this talus slope is made of come from? How did it get there? Check out the roots of this tree. I wonder, did this tree intentionally grow its roots outside of the soil when it began to grow them? If not, where did the soil go? This tree is on sloped ground. I wonder what happens when trees grow on sloped ground compared to trees that grow on level ground. Do trees on level ground also expose their roots in this way? The next time you find yourself outside, consider taking an erosion scavenger hunt. Look for evidence that the Earth's surface around your neighborhood or home has changed over time, whether it be quickly or slowly over several years. One suggestion for you is to look for places where you know water to flow down a slope. Sometimes these can be natural, like off hills and nearby playgrounds and parks. Other times they can be man-made, like just after the downspout from your house, where water flows off your roof and into those little channels that come out through the pipes. Anywhere where water is flowing is likely a place where you can find evidence of a changed surface.